Here is the second video for 6.5. We're going to go through examples 5 and 6 on this video. So let's start out. The monthly rents for a 2-bedroom apartment at luxury Cambridge Hall Apartments for a 9-year period are given on the table. Find and use the exponential regression equation to predict the rent in 2015. Now, to be able to do this, we're actually going to use our TI-83 calculators. And at the beginning of this particular unit, at the beginning of Unit 6 as a whole, you'll see some instructions on how to go through the exponential regression equation. So the first thing we need to do is actually chart it. And so to do that, on your TI-83s, I need you to click on where it says Stat. And if you look for your second button, it's a yellow button. Right below it is an alpha button that is green. Go 2 over from that and you'll see the Stat button. Now I just need you to click on Enter where it says Edit, and you should see List 1, List 2, List 3. We're going to go under List 1, and we're going to enter this into the calculator. And so for this, you're going to go ahead and list 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, and 2010. So it's going to be just as you listed it there, is going to be under where it says L1. Next, you're going to go ahead and toggle over to the second area, and you're going to list the corresponding numbers in list 2. Now make sure that the numbers line up. Make sure that however many you had in list 1, that you have the same number of entries into number 2. So once you've verified that they all work, it should look like this in your list 1 and list 2. Next thing you're going to do is you're going to go back to Stat. You're going to go 1 over. You're going to be, it highlights where it says Edit. You're going to move over where it says Calc. And then you're going to go down until you hit number 0 with a down arrow. And it says EXPREG for exponential regression. And you're going to hit Enter 2 times. Now, if you did this correctly, in the calculator, you're going to get that A equals 2185.288. And it goes on, but I'm going to go ahead and stop there at 288. B equals 1.051. So now we're going to go ahead and plug that into our exponential regression formula, where A, remember our formula was y equals A times 1 plus r to the n power. So when we plug that in, we get y equals 2185.288 all to the 1 plus 0.051 or 1.051. And I'll go ahead and take off that plus sign. It's 1.051. And it's all to the 15 minus 1, which is 14th power. Now going through that, once we've completed that, now I'm actually going to address real quick before we move on, how did I get that? Well, remember here it was to the x minus 1. Well, in this case, x is our 15 for the year 2015, minus 1 gives us the 14. When we plug that in, we get $4,384.77 And that is our rent in the year 2015. Go ahead and press pause, look at this you do, come back when you're ready. Okay, it says examine the regression equation from example 5. To the nearest tenth of a percent, what was the approximate annual rent increase in the Cambridge Hall apartments? Well, if we remember, it was y equals 2185.288 times 1.051 all to the 14th power. Now, if we remember back from example 4, right here is talking about 1 represents the 100%. The increase is actually identified right here. So I have 0.051, moving the decimal over twice. It has a rent increase in our exponential regression here of 5.1%. All right, last one for this particular unit and chapter. We're into example 6. It says in 2000, the price of cooperative apartments soared until the economic recession of 2009. In 1995, Ruth and Gino, they bought a co-op for $98,000. They borrowed $75,000. Years passed, they wanted to sell the co-op, but the price had dipped all the way down to $61,000. They know they have $6,744 in equity. So let's go ahead and see. It wants to know how much are they going to have to pay the bank back. We know that they're upside down would be the term because they owe more than what it's worth. The loan amount was the $75,000. And we know that they have $6,744 of equity based on that loan. So when we subtract that, what it means is they still owe $68,256 to the bank. So they owe that to the bank. Well, it says here prices dipped to $61,000. So if we take that $68,256 and subtract what it sells for, the difference is $7,256. So right here is what they will owe the bank after they sell their home. Go ahead, press pause, solve this last question, and then we'll be done for this unit. All right, here it says Paul borrowed B dollars from a bank when he bought his co-op for C dollars. Sorry, that's right there on the edge. He built up equity and paid back D dollars towards his principal. The price dropped $23,000 since he bought it, right? An inequality that expresses the fact that the new decreased price of the co-op is less than what Paul owes the bank. So C was the amount that he bought the condo for. And we know that it has now gone down. It doesn't really matter what its price was when it was bought. We know, though, that it's gone down $23,000. And the less than, it is less than what he actually owes. And B is the amount that he borrowed. D is the amount that he has paid to date. So we would subtract D from B to get the current balance owed. And we know that it is greater than what the price is that the co-op would sell for at this point. All right, good job, everyone.